Okay, so the focus of this talk is around R-Chord, residential chord, and VOLTHA. So this should be a pretty familiar picture. The focus is around disaggregation. So as you're looking at this, you're going to see components like, for example, the CPE, ONU, OLT, and BNG, which is part of our traditional R-Chord deployment, or traditional residential deployment. As we look at disaggregation, what you want to do is follow these blue lines. Components that we introduce are VOLT, VSG, and vRouter, which takes aspects of the OLT and the legacy deployment and disaggregate them into other functions. So what you'll see as part of this talk is we'll take a look at how these functions are disaggregated and deployed. So residential chord. So as Timon and Oz had mentioned earlier, right, XOS is our service deployment platform. As part of the service graph, what you're going to see is essentially a set of control or functions that are deployed as part of the fabric so that we can actually push functionality down, and that can be handled within either the access devices or within the switches, as well as data plane services that can be run in VMs, containers on x86 servers. So as part of this service graph, what you'll see is you'll have your residential subscribers. You'll have your control functionality, such as the OLT and AAA DHCP relay that can be run on top of ONOS, our controller platform. You'll have other functionality, such as the subscriber gateway, CDN, that can be run on top of, as containers on x86 so that your traffic can essentially go through the data plane. And then your vRouter functionality that allows you to connect to upstream networks. So we'll take a different look at this disaggregation. So what you'll have on this side is your multi-vendor ONT, ONUs, your residential gateways. As we look at some of the VOLTHA work that is going on, you'll see the introduction of kind of our next-gen white box OLT that we're introducing by EdgeCore, which consists of Maple and Qumran chips. And then you'll see a mixture of chord deployments, right? So you've got your VOLTHA. You've got a VOLTHA agent that provides abstraction of these components running on servers. You've got your, what we consider the data plane services running on servers also, tied together by a fabric. And then you've got your control functionality that is running on top of the ONOS controller with functionality such as OpenFlow that is provided by some of the abstraction layers. So just a brief flow through this, for example, is let's say you have a ONU. It comes on the network or you deploy it, it gets discovered. What happens is, as part of this functionality and our integration with OpenFlow, you're going to see that you get a port event, and then we can actually program flows such as S tags, C tags in order to take that traffic that ingresses the system and put it towards the VSGs that are more subscriber specific. So let's take a bit more in-depth look at this. So disaggregation of the OLT and VOLTHA. So traditionally, as we look at the OLT, they tend to be very proprietary and vertically aggregated products, right? What you'll have is they're very vendor-specific. So what you want to do, or what we wanted to do as part of the initial chord POC, our chord POC, was we took this vertically aggregated system and essentially disaggregated into the following components with a mixture of hardware and software. We'll start off with the bottom layer. So the bottom layer is essentially a 1U unit, Celestica made, and it uses a micro-semi chip. As we go up the stack, what you'll see is communication via LTO CMI, and this is the layer I wanted to talk to you about. We have something called a VOLT agent. The VOLT agent allows us to abstract the hardware and provide essentially a northbound of OpenFlow and netconf that allows management systems and SDN controllers to actually control this system. Right, so on top of it, you can do things like a VOLT application, AAA. This allows us to do is, as you have ONUs that come into the system, information is sent so that from a northbound standpoint, it looks like you've got a OpenFlow switch with a bunch of ONU ports. And as traffic comes into or the ONU is discovered, we can push down flows that says, okay, if you have traffic such as EAPOL messages that come in, send it up to me. I will talk to a Radius server, understand what S tag, C tag should be applied to this subscriber. And then this way, as their traffic ingresses the system, we can push them to the appropriate data plane services on the network. So if you look at the list of vendors, how do we take the stack that we had before and expand it so that we can support all of the folks that are interested in participating in this ecosystem? So if we look at the current stack, in order to take the existing model that we had, the disaggregation model, we would have to do something like this. So for each vendor, we would have to have a separate agent. What we wanted to do was, this became a fairly unwieldy problem, right? So what we want to do is, from a northbound standpoint, be able to abstract that and provide leverage across the different vendors so that they can make use of a common stack. This led to the introduction of another project called VOLTHA. VOLTHA is the virtual OLT hardware abstraction layer, essentially. It's a microservice-based platform that provides a core that can be leveraged by a bunch of different adapters that are vendor-specific to talk to their devices. So what you'll see as part of this is you'll get a common northbound that allows you to be able to communicate via REST, via OpenFlow, netconf, using a microservice-based core that provides common functionalities such as console, a key value store. We use Docker Swarm to be able to deploy a bunch of different Docker containers. Services are provided in terms of Dockers. You get centralized logging. You get eventing that would go to anyone who wants to subscribe to it, right? And then what the vendors can do is they can provide adapters. What the adapters provide is the abstraction of specific communication protocols to their individual boxes. And what we introduced as part of this was the Edge Core Whitebox OLT using an adapter which we call the ASF-VOLT 16 adapter. And so what this allows us to do is be able to share a common microservice-based framework that allows us to scale from an HA standpoint. So for example, in the recent release of the 1.0, there's HA support, backup resource support in terms of being able to back up the console KV store, and be able to abstract all this via a OpenFlow agent that sees the OLTs as essentially switches with ONUs as ports that they can configure. So as we look at the stack, how does that change with the introduction of VOLTHA, as well as our new adapter? Right, so previously what you saw was the adapter, or the device that we had supported GPON. With the introduction of the Edge Core box and adapter, what you'll see is it supports XGS-PON, which allows us to do 10 gig. It's based on the Broadcom Maple chip, and also supports Qumran switching chip. Communication is through the BAL API over gRPC. We've got the abstraction via the VOLTHA. So what you'll see is the VOLTHA core, and all you have to do is add an adapter. So it handles upon specific details and communicates using BAL. but that is abstracted via the adapter. From a northbound standpoint, it can communicate via OpenFlow and netconf, so that as ONOS provides functionality such as DHCP, IGMP snooping, all of those could be flows that are pushed down onto the access device, onto the switch, so that it then takes that information and programs it appropriately in terms of VLAN tags. The next thing we want to cover is how are we disaggregating the BNG? The BNG is disaggregated through the virtual subscriber gateway and through the vRouter. The virtual subscriber gateway provides the per subscriber functionality for the CPE and BNG. So what we do is for each subscriber, we create an instance of that service for the subscriber within a container, within a VM. And so the VSG essentially runs as a VNF in a container. It provides functionality like DHCP, DNS, and NAT, but also additional services like parental control, being able to control or bandwidth limit your upstream traffic, be able to suspend traffic going to the internet. There are lots of services such as CDNs that you can put into this path as you have your per subscriber data path in the network. And then the router. So the vRouter provides access to the upstream network. So what you'll see as part of this is the vRouter provides essentially the communication between your pod and the upstream network through metro routers. Your metro routers communicate via OSPF and BGP. We're actually currently leveraging an open source routing stack called Quagga. And what Quagga provides us is they're actually deployed as VNFs on VMs. We communicate via OSPF, BGP. As part of that, you'll have to configure routing configurations so that it can peer with the upstream BGP or the upstream routers. What happens is routes are advertised, they're learned. Learned routes are sent up to our vRouter control application on ONOS. These are put into a routing store, which is then used by the fabric control in order to push those routes down to the system. And what that allows us to do is for devices or hosts that have public IPs, they now have access to the internet. So the RCORD roadmap. The next step in terms of RCORD is we have an RCORD POC. As part of the upcoming release in Cord 4.1, we're integrating RCORD with the latest Cord release. What we want to do further is we want to take, so currently VOLT is supported, right? VOLTHA itself is actually a different project that is, has a very vendor-rich community working on it. And the next step for us is to integrate that support into RCORD so that various vendor devices can be supported as part of RCORD. So that's the first item you'll see here, is we want to integrate VOLTHA with RCORD. We're looking at the next major release of Cord to do that, which is satisfying Cactus, which is probably like the 5.0 release. And then what we want to do is add automated deployment of VOLT and vRouter. What that means is we want to be able to auto-deploy Quagga in a VM. We want to be able to build it so that as part of the core deployment process, you're not having to manually add a subscriber, right? It's provisioned as part of the full process. So we learned about an ONU, the VLANs are provisioned, we spin up a VSG container, all of that would be fully automated. And of course, Timon mentioned the P4 work we're doing and the demo that we're doing. So P4 is an effort that we've put a lot of focus into because it allows us to be able to leverage all those, the programmability to be able to do things like implementing VSG functionality. So we would be able to do things like QoS, PPOE termination. We would be able to look at putting VNFs or leveraging hardware so that we can essentially program VNFs into hardware, be able to leverage the speed and capability of the hardware to provide some of this functionality. And then, as was mentioned, multi-access cord. So our cord is part of that, being able to leverage one pod and provide various functionality, RM functionality in the same pod. As I've mentioned, VOLTHA itself is actually a very rich community with its own set of vendors that are contributing to it. As you saw the list, there are lots of vendors, and a lot of it is actually driven by POCs. So AT&T is actively participating in this project in order to leverage the work that is provided, the edge core adapter support, the functionality, the HA functionality, the features that are being delivered as part of 1.0 into their POC testing. And what we're looking at is an even broader effort to pull in more service providers so that as vendors are contributing to this, they would be able to leverage the work that they're contributing and be able to work with other service providers to provide that functionality and test with their system and go into lab trials, field trials. So what you'll see here is vendor has its own set of releases. We recently released version 1.0, which was the microservice-based platform that I talked about. And then with 1.1, which is very, very close to being released, there will be support for that white box OLT adapter. So we're looking at September, October. With the 1.1.x maintenance release, currently there are lots of vendors that are in POC trial with AT&T. We're leveraging that effort to make sure that the platform itself is pretty solid. So the issues, the gotchas that are found there will be addressed as part of what the 1.0 or 1.1 release. So that we can start pushing in further into trials. So for example, there's going to be some trials coming up that will be leveraging the 1.1.x as well as the 1.2. So the 1.2 release is slated for later this year. It's actually going to add functionality to the adapter, such as device management, support for alarms, reference ONU adapters. So we're currently looking at Broadcom, TNW as some ONU adapters. And then the next major release is going to be 2.0, and we're looking at about a 6-month window after November, so around May of next year, with a slew of new features. Someone had asked about continuous integration deployment. One of the things that we want to make sure we do is we want to start building reference implementations of a VOLTHA pod, make sure that it's deployed at one of the maybe service provider sites, and this way it allows us to go through as we bring in all of these vendors and their community development efforts, we want to be able to test against these reference implementations to make sure that functionality works. We don't want to wait until the end and try to pull in all the contributions from all the vendors. Other functionality would include being able to decouple the adapter deployment, for example, from the VOLTHA core, which allows various vendors to come in with their functionality independently. And there's a slew of new features such as G.fast support. Telefonica is looking at GPON support. So we'll be seeing a lot more of that and investigating with the service providers the functionality they need in what time frame for what trials. And this community will be helping to deliver that. In conclusion, our cord allows us to disaggregate the residential broadband access in terms of the VOLT, in terms of the VSG, and vRouter. The reference implementation is intended to be fully open, leverages white box hardware, and then the control functionality is implemented in ONOS in terms of the AAA authentication, being able to push flows down to make sure that the S tags and C tags are provisioned. And of course, with VOLTHA, it allows us to provide abstractions so that we can support many vendors as they bring in their hardware. And of course, we want to make sure that we eventually get to a fast path that isn't entirely in hardware. Okay, I think that was all I have. Do you have any questions?
Yeah, you're talking about residential edge networking, but cable companies do also a lot of edge computing. Is AirCord also going to provide for for the cable companies, or?
Yes. Wait.
I'll say that you may have noticed that Comcast is one of our 8 partner operators with us, and we actually are doing things around a virtualized CMTS and work in that regard. You know, we can't talk publicly about things that our operator partners haven't announced yet, you know, on their own. But there are some things that are definitely moving in that direction. So there's definitely an application in the cable space. And almost everything you've seen around cord and around ARD cord has application, I'd say, in the cable space. Okay. Yes, you know.
Any other questions before the break? Going once? Going twice? Okay, well, thank you so much, Uyen. Thank you very much.
Okay, thanks.